In this session, we are going to learn about the determining the centroid by method of moments or analytical method. In the earlier session, we are learn about the how to determine the centroid using the first principles or integrals, and we are also seen the graphical method of finding the centroid a little bit. For the integral or from the first principle, the centroid can be found by using a smaller strip or differential elemental area. That means very small area is represented as a strip or a thin line. The entire area is being divided into these differential elemental areas, and for that we are making a equation of a strip, and we are applying the boundary conditions of its lower to the higher limits. After that we are getting the integration. So for that example we took rectangle and isosceles triangle and circle. So for the circle, what we have do that we take the reference axis at the center. You please note here, we are taking the reference center as an axis, and we took a strip in the parallel to the x-axis. Hence, this length has been taken as 2x, that is x plus x, that is the width of the strip, and its height is dy. Hence, the differential element area is considered is 2x dy, and we, in order to get the dA and for integration of x value, we are used the property of the circle. The property of the circle is r square is equal to y square plus x square. From that, this x star has been obtained. This x star has been obtained from this equation. After obtaining the x value, we are submitted the same value in the integral equation, where y dA qx equal to y dA, integral of y dA. So dA is replaced with the 2x dy, and x is replaced with the square root of r square minus y square, and boundary limits are given for this, being it is an origin. This is the positive r and this one is the negative r. Therefore we are given negative r and positive r. And for this equation to solve, like this equation, if it is to having the roots, square roots, it is difficult to solve. Hence we are assumed this under square root term as a t square, while you are also doing the same thing in mathematics. And from that, by differentiating on both sides, we got the 2y dy value, where we have the 2y and dy here in this equation. Hence the 2y dy value is 2t dt, that is minus 2y dy value is 2t dt. Hence for 2y dy value we are taken minus 2t dt, and whereas the square root of r square minus y square is equal to square root of t square, hence it will be t. And then after solving and applying the integration and applying the replacing of the t value as in terms of the r square minus y square, and boundary values are substitution, you got minus r to plus r, it will be 0. Remember why the centroid qx if we are getting the 0, because we are taking the reference axis as origin at the center of the circle. Hence centroid, if we take the origin of the reference axis are the center of the symmetrical axis, hence the centroid of the circle is 0. Instead of taking the origin of axis at the center of the circle, if we take at the leftiest and bottommost areas, that would be some more different. So now this will be the centroid value. This will be equal to the r. So that we can say simply because it is 0 at that point. Hence, similarly, if you do the vertical strip and integrating, you will get the qy equal to 0 or x bar equal to 0. That implies the centroid of the circle is its center only. In other words, we consider the axis at the bottom and the left of the circle. So if we consider the axis at the bottom, that means this is at the bottom line, and left of the circle, so this is the left of the circle, then the centroid would be d by 2 and d by 2 are radius. So that will be the scenario. Because of the symmetry, both the values are the same. And graphical method of finding the centroid is it has some simple procedure. Whatever the shape given, it should be divided the area into discrete elements. Like if an area is given of any shape like this, then make it into some strips like this. Make this one as some strips. Then this entire area is concentrated at some point. So this area is A1. Let us mark this is A1. This is A2. This is A3, A4 like that similarly. Now what you have to do that, just take some scale. Those areas, take some scale to as a to develop the area polygon, to develop the area polygon and funicular polygon. Those will be like this. So this is A1, this is A2, like similarly A3, A4, A5, A6 like that, all the lines you have to draw. After drawing these lines, take some pole O, this is like this, take some pole O, a reference point which is some pole O, and this AB is equal to area 1 A1 only, and BC is equal to A2 area 2. So you have to draw like this a continuous area polygon by combining these at the pole point. Then parallel to AO, so take some parallel to AO. This is the parallel to AO. Draw from A to other side of the A as a parallel line. Similarly, B to O, from the B, draw a parallel line at the BO, and similarly CO like that. Similarly, continue all these things. Then after that, add all those extensions like this. You can extend, it will be meet here. Like similarly, extend all the things. Then you got the resultant. That resultant will gives the x bar value. That resultant will gives you x bar value. Similarly, you can divide this strip into vertical side also, then you will get the y bar. So repeat the same procedure to obtain the direction. So for this condition, what we have to draw that pole diagram or area polygon and funicular polygon. So pole diagram is required and funicular polygon is also required to generate the centroid using the graphical method. In this session, we are going to learn about the next method of finding of determination of centroid by the method of moments or analytical method. you can say it is or by the analytical method. This method is also known as analytical method. Right? And by using this method, we are going to determine the centroid of a trapezium, dam shapes, wide areas, that means negative areas, that means hollow portions. If a object containing a hollow portions also, we will calculate how the centroid is going to be affected with the hollow spaces. So we will see that part of the thing in this session, and we are also dealing with the simple composite shapes, that is nothing but a trapezium shape, like dam shapes, and some combination of the different shapes. We will see those things. So first we will see the what is the analytical method, what it means by the method of moments. We also done the method of moments principle used in the calculation of first principles, where we done that qx by a is equal to cx, or centroid in x direction, that is from y axis, we determined. So in that particular integral equation, the qx is nothing but first moment of area, first moment of area. That means we already used this concept of moments in the integral or first principles, but where that process is required integration. Now in the analytical method or method of moments, we are not going to use the integration process. So it is the only summation by using the sigma methodology of the qx constants. Analytical method is also known as geometric decomposition method. Geometric decomposition method, that means if a bigger area of irregular surfaces is given that has been divided into some parts of the known shapes, that means decomposition. We are making the geometry into small parts of the basic shapes, and it is also known as method of moments or using principle of moments. For determination of centroid, it can be used for the discrete areas, composite shapes, and continuous areas. For analytical method, if we take an irregular shape like this, if it is an irregular shape like this, there is no specific formula is can be applied for this to determine the shape of the centroid. Hence, what we are going to do that we will divide it into small number of segments of areas, that is to be a known shapes, approximately known shapes. It not so much accurate, but it is approximately known shapes. So after this capital A of the total area has been divided into number of segments A1 to A6, up to 6 parts it has been divided, or you can say n number of parts you can also be divided along the y direction. Hence, if we divided the area in y direction, you will obtain the x bar value. If we divided the area into x direction, then you will get the y bar value. So it is a reciprocal. In this case, we are divided into the parallel to the y axis, hence to obtain the x bar value. After division of number of segments, we are going to calculate the each part area. A1, A2, A2, A3 like that. We are going to calculate the each areas. And after that, being it become a simple basic shape, we are going to locate this centroid in terms of the x bar, x value for each segment from the references axis. Please understood, from the reference axis. It's not that for the same x value will be taken as this is the x2 value, not like that. X2 value has been from the reference value, that means always from the axis to the referred area. If I say for the A4, this is the centroid of the A4 area individually, because it might be between these 2 points, but the distance has to be counted from this point to referential axis is this point. So this is the distance of x4. So this is the distance of x4. So we have to take the values from the referential axis, not from the adjacent areas points. So please note that before solving to any problem, please note where is your references axis and calculate all the x and y values of individual segments or individual shapes from those references axis only. Right. So to get the same thing, after obtaining the x and area, you can easily to obtain qx and qy, because qx is equal to ax, qy is equal to ay. Now there are n number of segments of areas are there, hence qx is equal to sigma ax and qy is equal to sigma ay. That means a1 x1 plus a2 x2 plus a3 x3 like that. And qy means sigma ay, that is equal to a1 y1 plus a2 y2 plus a3 y3 like that. Similarly, to in order to get the centroid of the whole the object cx or cy, that I am telling as cx and cy, because centroid about the x-axis, centroid about the y-axis. So these terms are used for the a composite shapes. Therefore, cx or x bar, we can also can be pronounced as cx or x bar. X bar is equal to qx by a and cy is equal to qy by a. So with this process you can obtain the composite shapes or irregular shapes centroid. Let you understand the procedure. The centroid of a plane figure can be multiplied or computed by dividing it into a finite number of simple figures. Now this entire shape has been divided into a finite number of simple figures. That means I broken this unknown area shape into the simple rectangles, right? So simple rectangles are broken. For computing the area of each point, now what you have to do, that each point area, this is a1, a2, a3 like that. Then compute the qx. In order to compute the qx, you require the values of x1, x2, x3, x4 like that. Then compute the qx value and qy, and then similarly cx and cy will be obtained as a x bar and y bar. So the similar procedure has been detailedly explained in the given below paragraphs. Let us consider the plane area A lying in xy plane. Let C be the centroidal of the total plane area. It is required to locate the position of centroid C with the respect to the reference axis like y-axis and x-axis. In this case, the reference axis is x-axis and y-axis. So here it is the y-axis as the reference axis, x-axis as the reference axis. Origin is here. Hence, where is the origin? This is the origin. Let us divide the given area into small elemental areas. So area has been divided, total area, and small elemental areas are A1, A2, A3. As shown in figure, let C1 and C2 be the centroids of each elemental areas A1, A2, A3. So instead of G1, you can also call C1, C2, C3, centroid C1, C2, C3. If it is have the volumes, then we have to call center of gravity. Then you can use the term G1, G2, G3 like that. So because it is a plane areas we are dealing, hence I am notating it as a C1, C2, C3. Centroids of each elemental area A1, A2, A3. Let x1, x2, x3 be the distances of the centroid. So this is the x1, x2, x3 from the y-axis. So where this is the distance? With respect to we are calculating the y-axis, right? So from the y-axis you obtain the x1, x2, x3. From the x-axis you obtain the y1, y2, y3 values. After obtaining those values, simply using the method of moments, you just multiply a1 x1 as we are did in the integral equation also a1 x1 where we are written yda or xda like that. So a1 x1 plus a2 x2 plus a3 x3 like that n number of areas. So once you know that qx value, that can be summarized as sigma ax also because it is a summation of product of areas and distances of centroid from the y-axis. So that can be known. After obtaining the qx, you can get the x bar value, that is nothing but cx is equal to qx by a. So this is the procedure you have to adopt to calculate the x bar value. For the similar procedure, we require to follow for the qy also. Qy is also a summation of product of the area into distance from the x-axis of their centroids. So that is given qx into qy. This one is qy. Therefore, qy is equal to y bar cy is equal to qy by a. So your accuracy may be improved by dividing the object into nearest basic shapes of the geometry. So the given circle area, if it is like this is of any shape, which can be made more accuracy by making it as simple as of the basic shapes. So convert, take number of areas so that it will give you like uh, this is the triangular shape and this can be a nearest triangle shape and this is also one of the triangular shape and this might be another triangular shape, this is like that another triangular shape. So like this you please convert to the your nearest basic shape which is possible to you, so that it will gives the increases your accuracy. Now you can see that this is an irregular area has been given. In this case, this is an irregular area which not resemblance to the any basic shape like a triangle, circle, rectangle. It is not come into the that or trapezium shape. Not this basic standard shape is not this. In order to get the centroid, we can apply the integral or first principle, which takes much more time for the calculation. Hence, in order to avoid this cumbersome of the calculation integral part, we are going to be use the analytical method or method of moments. In that particular case, we have to examine is there any possibility of this entire shape converted into basic shapes. What are the basic shapes? Rectangle, triangle, circle like that, trapezium like that. So convert this entire figure into the those possible rectangle basic shapes. Now you can see from this you can draw here a particular line which is becomes a triangular here, and by drawing here also you can have the one more triangle here and this will become a rectangle. So this portion is triangle, this portion is also a triangle portion and this one is a rectangle portion. So there are three shapes are there like that. Hence the same thing has been given. A1 is a triangular one and A3 is the triangular 2 and A2 is a rectangular portion. So calculate those values using the simple procedure which we are mentioned by the this particular formula A1x1 plus A2x2 like that to obtain the x bar value. And similarly, to obtain the y bar value, calculate a1 y1, a2 y2 and divided by the total area to get the y bar value. So this is the simplest procedure that you can obtain to solve the centroid. So for the entire centroid can be represented as a C, that will be C is nothing but C is equal to that C is equal to Cx comma Cy. So as a coordinate we can see that it can be Cx comma Cy. So this can be written as C is nothing but Cx comma Cy. So Cx and Cy will get from this formula. Right? That can be represented as x bar comma y bar. Come to the next understandable basic shapes. The combination of the basic shapes will result to a different picture, which we are already earlier seen that this figure is the combination of the triangle and rectangular shape. Hence it is the combination of the basic figures, hence we can say it is composite shape. Any object is made of combination of basic shapes or irregular shapes. More than one is known as composite shape. Or a figure that can be divided into more than one basic figures is said to be a composite figure or shape. See in this figure how this can be divided into a basic figure. So I can do like this. Now you please understood this is the figure 1 and this one triangle is the figure 2 and this one is 3. So I divided it into 3 figures, right? And similarly this figure of the trapezium can also be divided into 3 figures, right? So this one is a 1, this one is a 2 rectangle, all are the basic shapes. So this can be divided into 3 parts and this can be divided into only 2 parts. So this is the triangle. Hence this one is the part is rectangle and this part one is the triangle. So it is a figure that can be divided into more than one basic figure is said to be a composite figure, right? Now we are after understanding the analytical method, let me try to solve the some basic composite shape, that is trapezium. Determine the centroid of a uniform trapezium when the width of base is 250 mm and top is 150 mm and height is 80 mm. Here he has mentioned that a simple word is uniform trapezium. It is it is a required one for to draw the trapezium. Trapezium can be of either of the shapes. The trapezium can be like this. This is also trapezium where this slant is not equal to this slant. Hence, he has mentioned here, it is a uniform. It is a uniform trapezium. That means the slants of these both are same. These both are same. In order to get that, the total given width is 250 mm at the base and at the top is 150 mm. The difference between these two will be 100 mm. So this difference is 100 mm. So this difference is 100 mm. So this 100 mm has to be equally distributed to the both sides. So that is the constant he is giving that to understood as this is the uniform trapezium meaning. So hence this also a 50 mm. Now this entire trapezium will become a uniform trapezium because of the slant heights are equal from the for the uniform trapezium, right? So after drawing of the trapezium of the given dimensions, let you composite figure is divided into basic shapes. So try to devise these basic shapes. What are the basic shapes are available here? This one is A1, A2, A3. That means A1 is a triangle, A2 is a rectangle, A3 is also a triangle. But please understood, A1 is placing like this triangle. This is the left corner is 0, whereas the A3 is left corner is having some perpendicularity, it is not the 0. So that makes both the triangles are different. Both the triangles are different. And please also note that we should locate the origin. In generally, we want to place the entire object into the first coordinate. That I am already mentioned you that please locate total figure into first quadrant. So that is most important for the get the solution. So in order to get the transfer the total object into the first coordinate, identify the bottommost line as the x-axis. So this is the bottommost line, and identify the leftist part of the total object. So this is the leftist portion to give the y-axis. So now this entire figure is came into the first coordinate, right? So now this is the our origin. So calculate the x values of each one from A1, A2 and A3 with respect to the your origin. So this is the x2 from this point. So like that, and this one is x1. So x3 from this point to end. So always measure the x1, x2, x3 with respect to origin, y1, y2, y3 with respect to origin O. So procedure is very simple. So we are identified the origin here. We are identified the origin. After that, with the references axis, we are identified the origin. Then we are calculated the each areas of the individual shape. That is the left triangle, right triangle, and rectangle. That is the middle one. And we are located those centroids C1, C2, C3 as a roughly, right? So that we can understood that there is a C1 means there is a x1 comma y1, C2 means x2 comma y2, C3 means x3 comma y3. So we need to calculate those x1 y1, x2 y2, x3 y3 values from the given figure with respect to the references axis, right? So calculate the areas of each part, right? And total area is required for the to get the centroid Cx or x bar and y bar. So hence you summarize the total values, total area values. Then references origin is O. From that, calculate the x value. You see this figure. This is a triangle shape from this point to this point. You know that this is h by 3 or b by 3. You can say this is b by 3. But origin is we are taking from this point to this point. We require this value. So this point is how much? So for this total b minus b by 3. B minus b by 3 that will be gives you 2b by 3. So please understood that b minus b by 3 that is equal 2b by 3, right? So that is the thing we are obtained here. Therefore 2b by 3 the value is noted here, and for the rectangle always we have to take the values from the reference axis. What is the reference axis? This is the O point is the reference axis. So from this point you need to locate this C2. Therefore x2 that is nothing but x2. So for this as a rectangle it is b by 2 that is 150 by 2. As a rectangle it is a b by 2 150 by 2, and this rectangle is starting from this point, not from this point. So we require to add this 50 mm for this also, hence we are added the initial base of the left triangle. Therefore 50 plus 150 by 2 125. So because we need to consider all the values from the references axis. Similarly, for the right angle triangle of the right triangle, which is taken as a reference from the axis, hence we need to add 50 plus 150 plus, we know that from this side it is b by 3. So from the perpendicular side it is b by 3. So here it is the perpendicular side. Hence it is the b by 3 only. So we taken b by 3. Right. So calculate these value and you are getted like this. Similarly for the y1 we need to calculate those values. For the right angle triangle it will be h by 3 the value y1 and y2. Y2 for the rectangle is b by 2 or h by 2, therefore h by 2, and for the y3 it is also rectangle same, hence h by 3. So after calculating these values we need to summarize as a qx and qy. Then in order to get the qx, summarize the product of ax, that is a1x1 plus a2x2 a3x3. Similarly for the qy, and then x bar is equal to cx is equal to qx by a, and y bar is equal to qy by a. So after that we are obtained that one is 125 and another is 36.67. That is nothing but x comma y, x bar comma y bar. The same has been located from the figure. If you are better understood, you can also get the 250 mm by 2 that is 125. You please note that without any much calculation of the x bar for this particular figure, you can simply say that x bar is equal to rcx equal to rcx or x bar equal to cx or x bar is equal to 250 by 2 that is equal 125. Because of this entire figure is symmetry about the y-axis. This is symmetry about the y-axis. So hence it is symmetry about the y-axis. It is symmetry about the y-axis. Hence you can simply by inspection you can say that it is 125 mm in the x direction. So this can be a symmetrical axis. So you need to solve in this problem only for the y bar, not for the x bar. So for these type of problems where there is a symmetrical axis is there, then you follow this simple formula for symmetry, symmetry, then x is equal to x bar. I can say that is x bar or cx, or cx equal to largest dimension, that means whole dimension, that is the total dimension, divided by 2, divided by 2. Simply you can do that. So largest dimension means here it is a total dimension, that is total dimension. So we can say that for the x bar, due to it is symmetry about the y-axis, the x bar value without any further calculations like qx is equal to sigma x, that is not required at all. Simply you can write 250 mm by 2 125 mm. But it is not the symmetry about the x-axis, hence you need to calculate qy value and then you have to calculate the y bar. Now, with this understanding, let me introduce the negative areas, that means hollow areas. So you please understood my term. I am using the hollow area or wide area as a negative area. So you follow that word negative area. That means it is not the positive area. So in this figure, determine the centroid of the given figure as shown below if the circle area is hollow. So this circular area is a hollow area. It is not the solid place, or you can say there is no plane in this sphere. That means no particular area is not there. It is cutted. This paper up to this portion is cutted. So this area is not there. If area is not there means we need to be subtracted it. That area should be subtracted while the calculation portion. So in this, if you are understood, in this we have the so many corresponding areas. If I am going to divide it, so the rectangular portion can be 1 and circular portion is second, and here up to this portion, if I can say this portion is up to is the rectangle, hence this is 3 and this semicircular area is 4 and this portion is 5. So from this figure I identified the 5 areas of the basic areas, basic shapes. Out of 5, the second area, which is a circle, is hollow, which is a negative. Now see the calculation, how we are going to do this calculation. So after identifying the which is a negative area, remaining all are I kept as a positive. You see that all are positive. 12,000 is positive. That is the rectangular areas is also positive. Semicircle is positive. Is all are positive. But you see this particular circle which is hollow, I make it as a negative symbol for the calculation of the areas. Automatically this sigma ax is also going to be negative and sigma ay value for the circle, particularly for the circle ax and ay, are going to be negative values because of the area is negative. That means area is not there, so we need to subtract that area, hence we are giving a negative symbol for that particular area. So this is the basic uh, hint we require to solve the this type of problems. So you please keep in mind which is the hollow or void which is going to be cutting that areas are to be that area is to be noted as a negative. Simultaneously, this ax will become negative, ay will also become a negative because area is negative. And furthermost, you please understood that there is no negative for the x and y of the same particular hollow areas or deducted areas. Here you see, I am not given any negative to the x value. I am not given any negative value to the y value. Because area is negative, our distances are not the negatives. So please understood that area is negative, area is negative, but not the x and y, but not the x and y. So please understood that one. So area is negative, but not the x and y. So remaining portion of the calculation is very simple. So for the rectangle, you know that figure. So our figure is like this. So this is the rectangle, and out of which it is a circle is there, and here it is also another rectangle portion, and here it is a triangle, and meanwhile it has a circle. Right? This is the thing. A circle is a hollow portion. This circle is hollow portion. Right? So for this rectangle, what we are going to that A1 area, and 100 is given. This distance is 100. 100 by 2 multiplied the ax, and y value, this is 120 is given here. This is the 120. 120 by 2 is 60, and same value for the circle. 60 is the dia, you know that 60 is the dia, hence pi r square or pi d square by 4, you use that term because circle is a negative, hence we are taking it as a minus value. And for the x, we are not going to consider any negative values, but we need to consider the references axis. So this is my references axis, so that all the object will be placed in the first quadrant. So from this point of view, this is totally 100, but dia is 60. 100 minus 60, that means 40. 40, this from this side it is a 20. 20 plus, and this 60 is the dia. Therefore 60 by 2, hence I got 50, right? Similarly, the y value is also same. This side it is 120. 120 minus 60, therefore 60 by 2, 30. Therefore 30 plus 60 by 2, 60. So that is the thing you need to calculate. And similarly for the rectangle, this is the portion of the top portion. So it is given rectangle top. So this is the top portion is the rectangle. 100 into 80, this is the 100, and from this point to this point is 80. Therefore 100 into 80 is the area, and x bar is equal to 100 by 2, that means x3. Similarly for the y is not this value, this is the mistaken value, right? So where this value could be written as, this value is the mistaken value. So it is by considering the references axis, the rectangular top for the y, 120 plus 80 by 2, that means from this point to this point 120, and this is 80, hence 120 plus 80 by 2, 160. Then multiply this one with the your area, you got this value. And for the semicircular also, which is this portion, semicircular area, this is this one, For this, pi r square by 2 or pi d square by 8, then calculate your area because it is half of the regular circular area. And its value of the x is 100 by 2, this is the 100. Hence, dia of the semicircle is also 100, 100 by 2. Then ax is calculated, and similarly for this, y you require to calculate from this point. So up to this point it is 120 and 80. Therefore 120 plus 80, 120 plus 80 plus, for this particular semicircular area individual is y bar is 4r by 3 pi. So we require to add those things. 120 plus 80 plus 4r by 3 pi. Then calculate that, you will get it. Similarly for the isosceles triangle, the same thing, x bar is equal to 100 plus h by 3, because after rectangular portion only this isosceles triangle is there. Hence this is the 100, so 100 plus h by 3, because h is here are, because it is a base for this triangle, hence this is become h. Therefore h by 3, that is 60 by 3. And for the y bar we require this dimension, that is half of the, because it is isosceles triangle, it is the b by 2. Then add the all the areas, because this is the area, so this will become a sigma a, this is the sigma a, right? And this will become sigma ax. Just add all the things, right? All the values, that is the total, right? Similarly sigma ay, right? So the values are obtained from the table, substitute in the formula, then solve for the x bar, right? And similarly solve for the y bar. You got the both the values. That means now x bar is 60.2. So from this origin, the x bar, that means distance in the x direction, is 60.2. So this is the 60.2. 60.2, and from distance of this one is towards the y direction, it is 91.78. So the same thing has been represented here. So this is the way to calculate for the void areas or negative areas given like this. Okay. Now this is a small exercise for you. Determine the centroid of dam when the width of base is 450 mm, top is 150 mm, that means base width is 450 mm, top width is 150 mm, and height is 500 mm. And note that water surface face is vertical. So the trapezium shape of the dam can be any shape. Hence, he is clearly mentioned that take the vertical surface as vertical. Hence, if I am considering this side is the water surface, if this is the water surface, this should be the vertical. And the base is bottom, that is 450 mm, and the top is 150 mm. When I make this as vertical, I cannot make it as a slant like this. If I make a slant like this, this will become a wrong, because he is clearly mentioned that water surface is vertical. So hence I need to take this surface as vertical, and the top is 150 you need to draw, and the base bottom is 450 mm. Draw up to this, then join the both the points. So this is the inclination you are getting. Now for this to solve, make it into two parts. One is a rectangle portion, this one is the rectangular portion, and this portion is a triangle portion. Then similar procedure adapt. and then solve the same thing. In this session, we learn about the determining the centroid by method of moments or analytical method. So we also solve the some of the problems like trapezium, dam shapes and negative area or void area or hollow shapes using the simple composite shapes. Thank you.